Hello everyone, this is the lecture for section 5.3, other trig functions. So in 5.1 we learned angles, 5.2 I gave you the basis for everything plus one more just because of the mnemonic that we've been using, right? We learned about sine and cosine and the third one tangent, right? There's three more that I have to show you. That's what we're going to concentrate on for this section. Thankfully though, it's based off of the other three. It's based off of sine, cosine, and tangent. Okay? That's basically what this section is, learning the last three. Okay? So, for this section, make sure, hopefully, I gave you all a nice unit circle, or at least you constructed it on your own so you know how it's supposed to look like, right? So, get it out, okay? And we're gonna be using it like fairly repeatedly for this section, okay? So let me scroll down a bit. So the first thing I need to remind everybody of, right, is SOHCAHTOA, okay? And I want everybody to look at how I'm writing these down, right? So if you have an angle theta, right, then sine of that angle theta, right, is going to be y over 1 if it is over the unit circle, right? If you have any rando size circle of random radius, right, then it's going to be y over r being that radius, right? And if you use SOHCAHTOA, right, that's opposite, right, over adjacent. Okay? Okay. I am going to draw a line straight down from here because I'm going to, whoa, that's a bit too thick there. How about we do that thick, huh? There we go. Bam. Okay. I'm going to do the next two. So cosine of an angle theta, right, is equal to the x over 1 if you have if your radius is of size 1, right? If you have a random sized radius, right, then it's going to be x over the radius r, right? And this, if you use SOHCAHTOA, is adjacent over hypotenuse. Okay? I'm going to draw another line straight down. And then there was the last one, tangent, right, of some angle theta. Okay? That one we defined as the y over the x, right? And if we used SOHCAHTOA, right, TOA is opposite, right, over adjacent. All right. So these are the three that we learned from whatever that section was, from section 5.2, right? All right. The last three, and like there's a reason why I separated them out this way, okay? The first one I want to show you guys is cosecant, CSC of theta, right? And I'm going to write it up above, cosecant, okay? That is defined as all of this flipped. That's it. So this is going to be equal to 1 over y. Okay. This is also equal to r over y for a random sized radius circle, right? And it's also equal to adjacent over hypotenuse. Okay. Now, there is one more that I need to show you all. Okay. And let me move this line over just a little bit. I'm going to do the same thing with this one. Whoa. There we go. Okay. Now, it's between these two. You guys see how cosecant is 1 over y? Yeah? And that is equivalent to that, right? So y is equivalent to sine. We have our first identity. I think it's called the reciprocal identities, if I recall correctly. Okay. Cosecant is also 1 over sine of theta. Let me write the sine nicer, huh? There we go. Okay. That is the definition of cosecant. The next one is secant of theta. Okay, you think I'm switching them, but I'm not. This one is definitely secant, right? And the other one is cosecant, even though the first one was sine and this one's cosine, right? Just get the names right. It's really, really easy to think that cosine and cosecant are related, but they're not. Okay? It's cosine and secant that are related. All right, so let's keep going now, right? So it's the same idea. We flip everything that's above. Okay, so this is going to be equal to 1 over x. If you're on the unit circle, it's going to be equal to r over x. If you have a rando size circle, right? And then this is going to be hypotenuse over adjacent. And just like before, we know that from here, the definition is that secant is 1 over x, and x is cosine, so another identity shows up. This is also equal to 1 over cosine of theta. Okay? And then the last one, and actually, I want to back this off our purple line here a little bit, just a little bit. There we go. Okay. And then our last definition is cotangent, C-O-T, of an angle theta. Same idea. We switch everything. X over y, which is the same thing as adjacent over opposite, right? And just like before, this one has a trippy identity that I'm about to cover, because I've given you all the parts before. I just haven't shown you this, right? Tangent is equal to y divided by x, right? We know what y is, right? And we know what x is, right? So that gives us another identity here. This is also equal to sine of some angle theta divided by the cosine of theta. Okay? Okay. So now that we have that identity, right, the next one should make sense. The cotangent is going to be the cosine of theta over the sine of theta. Okay? And I'll give you one more. This is also equal to 1 over tangent of theta. If you grab this one, let me actually highlight it in pink. If you grab this one and this one and actually play around with it, right? Do your the division of fractions, you flip it and make it multiplication, all that stuff, right? If you do all that, you'll find out that both of these are equal. Okay? There we go. That's the final definition. These are the 6 trigonometric functions that we're going to be using for the entire rest of this is actually all of the trig functions in all of math that we're going to be playing around with. This is it. This is it. Okay, so now let me scroll down. So these work the same way you think they do. Nothing different. Okay, so for example, for this one, we know that point is on the unit circle, right? So if you take a look, negative root 3 over 2, comma 1/2, that means my x is negative, right? And my y is positive. So it looks like my circle is going to go, whoa. Actually, let me draw the circle first, huh? Just go like this. Well, that's pretty good, right? Okay. Bam. So my angle always starts here and goes all the way to its terminal side, so way up there. Okay. This angle right here. Actually, let me do it in blue. This angle right here. That's my angle T, right? Okay, so we know that the coordinate here is negative root 3 over 2, comma 1/2. That is that point right there. Okay? It's exactly how you think it goes. Sine of t. The sine is always going to be the y portion, right? So this is going to be 1/2. Cosine of t, that's supposed to be the x portion, right? Negative √3/2. Tangent of t, this one's the one that we haven't been working too much with, right? According to my definition from up here, that should be y divided by x, right? So it should be my y, 1/2, divided by my x, minus √3/2. Okay? You can also use this right here, that it's equal to sine divided by cosine, right? And we found sine and cosine already, right? Now, if you do this all right, this is going to be equal to negative √3/3. That is the three basic ones, right? That's sine, cosine, and tangent. Okay? Now let's do the other three, right? I'm going to do, cosecant of my angle t, secant of t, and then cotangent of t. Okay? And there's a reason why I kept saying it's just these three, right, are the initial three, the ones above it, just flipped, because that's exactly what it is. So cosecant is supposed to be sine flipped, so it's going to be 2/1, and that reduces to 2. Okay? Secant is cosine flipped, so this is going to be negative 2/3. And this is equal to 2√3/3. If you do all if you do the multiplying of the square root from the bottom and everything, right, that's what you get. Okay? And then the last one, right, is supposed to be, if you take a look at this, right, it's equal to cosine divided by sine. So I should be able to grab cosine. Negative √3/2. Whoa. Let me make it nicer, huh? Negative √3/2 divided by 1/2. Okay, and if you do this appropriately, you get negative square root of 3. Bam, we are done. Okay, there's a fair amount of playing around with fractions here that you might need to get comfortable with. So if the movement, if you don't work this out on your own and you still get stuck on how did I get this? How did I get this value? And how did I get this value, right? Ask me during class. Ask me during the example. Okay? All right. What comes up next? Quick checks. Okay? We'll try these out in class like I usually do, right? Okay. Coterminal angles and reference angles. Okay? Gotta get a drink of water there. My throat feels a little dry. Okay. So, there were 3 angles, right? There are 3 angles that we have to look at, and each one, right, has 6 trig functions to look at, right? So that makes just the 3 important ones times the 6 trig functions, right? That makes 18 pieces of information, right? Okay, that is a lot just for a piece, right, of my unit circle, right? Got it? But what we can do is we can use reference angles, right, to sort of basically reduce our work. To basically reduce our work. Okay, so let me show you guys what I'm talking about. I'm going to use reference angles to find all 6 trig functions, right, of negative 5 pi over 6. Okay, so first thing, actually, let me do this. I'm going to grab this, copy, paste. I copy paste. Oh, come on, come on, come on. There we go. Bam. I just grabbed the unit circle and threw it into our notes. Okay. Okay. So I am looking for this negative 5 pi over 6, right? So I'm going to go to my unit circle, okay, and I'm going to go ahead and find it. Okay, and if oh, come on, I want to make the unit circle a little bigger, but I'm on my desktop computer, so bam, there we go. Okay, so if you guys recall, right, when I do angles, this is my initial side, right? And if it's a negative angle, I have to go negative that many, right? So I'm counting pi over 6s, okay? So if you guys recall, it's this one, this one, this one, this one. These are my pi over 6s that I have to count, okay? So I have to go negative 5 pi over 6. So 1, 2, 3, 4, 5. This is my terminal side right here. Let me actually do it nicer. There we go. This is my terminal side right here. So this right here, whoa, let me do it a little thinner, huh? There we go. This right here is negative 5 pi over 6. Okay, now look at what happened. Look at where I landed. I landed on 7 pi over 6, right? This is the point behind reference angles. Do I need to memorize the stuff for negative 5 pi over 6? No, I do not. It landed on 7 pi over 6, so I can use all the information for 7 pi over 6 instead of going to negative 5 pi over 6. Ta-da! Okay, we have everything we need. We need these x and y values. So if I want to find all 6, right, I'm going to do sine of minus 5 pi over 6, cosine of minus 5 pi over 6. Let me do the first 3. And tangent of minus 5 pi over 6. Okay? We are going to use that highlighted yellow point. And we are off. We're off to the races. So the sine is going to be negative 1/2. The cosine, negative root 3 over 2. Okay? And then the tangent is going to be negative 1/2 divided by negative root 3 over 2. And if you reduce this right, root 3 over 3. Done, done, done. Those are the 3. At least the 3 first ones, right? The next 3. Whoops. Whoa. Cosecant of negative 5 pi over 6. Secant of negative 5 pi over 6. And then cotangent of negative 5 pi over 6. Equal. We get to flip all of these. So this is going to be negative 2 over 1. Let me make it 1. That's negative 2. This one's going to be negative 2 over the square root of 3, which is negative 2 root 3 over 3. And then the last one is going to be negative 3 over the square root of 3. And if you do everything right, negative root 3. We are done. Bang, bang, bang. Okay? This is the point behind reference angles. This is the point behind coterminal angles. If you recall when I showed you guys that in section 5.1. We use reference angles. We use coterminal angles, so we don't have to use reference angles and coterminal, so we don't have to memorize all of these values. We just memorize at least what's on the unit circle, and we are happy with that. All the sines and cosines and tangents from the unit circle is enough. We don't have to do anything else. Okay? All right. Quick checks. Having you guys try these out. Okay? Okay. Moving on. You guys remember odd and even properties, right? So, from way back from chapter 1, okay? Odd properties. A function is odd if the f of negative x, if you plugged in the negative x into f, right? And you got the negative of the original, that was odd, right? If you plugged in the negative x into f and got the original, flat out original value, right? Then you had something that was even, right? So it turns out all our trig functions have the same sort of grouping. Okay? Even functions are cosine and secant, right? And the odd functions are sine, cosecant, tangent, and cotangent. Okay? Notice how they're grouped. Okay? If you recall, right? If you recall, cosine and secant, they're related, right? Secant is 1 divided by cosine. Okay? And then over here, right? Sine and cosecant, they're related, right? Cosecant is 1 over sine. And cotangent is 1 over tangent. They're related, right? Okay, so now, just to paint a picture of why, right? Why are these true? Why is this true? So basically what I'm saying here is this. Let me write down the odd and even statements for all of these, right? If I grabbed cosine of negative x, right? That is equivalent to just the positive cosine of x, right? Let me actually make them a little smaller and group them. So cosine, my goodness, my handwriting. Cosine of negative x is equal to cosine of x, right? And then secant of negative x is equal to secant of x. That's what it meant to be odd. If you plugged in the negative of the angle, right? If you plugged in the negative x, right, then that is equivalent to just getting the original back. That is equivalent to getting f of x back. Done. And then the other ones, right, they're odd. So sine of negative x is equal to negative sine of x. Cosecant of x is, negative x, sorry, is equal to negative cosecant of x. Tangent of negative x is equal to negative tangent of x. And then cotangent of negative x is equal to the negative cotangent of x. Hopefully you guys see how these work out, right? All of these are even. So then no matter what I plug in, the positive or the negative angle, right? They give me just the positive, the regular function back, right? And all the other ones were odd, right? So if I plugged in the negative x, right, I get the negative of the positive one back. That's the statement for odd. That's this one. Okay, so now the question is this. Why? Why is that the case? Okay, and that's easy enough if you look at the unit circle. So I'm going to only draw sort of half of the unit circle, the right side in particular. Okay, so here's the unit circle. Bam. All right. So that we know this is true, right? So let's say we go upward a particular angle theta, right? This has a coordinate. that. We know that the x component is the cosine, the y component is supposed to be the sine, right? Okay. Do the exact same thing, but we go downward this time. Let me make that a little thicker. Bam. There we go. Let's say now we went down that same amount theta. Correct? Okay. This also has a coordinate, right? This is supposed to be cosine of negative theta, comma, sine of negative theta, right? This is how, that's how our coordinates work, right? On a unit circle, yeah? But now what I want you guys to do is look at this, right? Both of these, they are on the same, right? They went over on the x-axis by the same amount, right? So then from here, we can see that the following is true, right? That cosine of negative theta is equal to cosine of the positive theta. Because these, right, on the x-axis, they moved in the same direction, the same amount. You guys see that? Okay. But the other one, essentially saying this, right? You guys see these two triangles? There's this triangle, okay? And then there's this triangle. Both of these triangles are exactly the same, right? It's just one is pointing upward and the other is pointing downward, right? But that gives us what we need, right? The same amount that we went up this way, right, is the same amount we went down this way. And the only difference is we went down an angle. We went down theta instead of up theta, right? That is this. So the sine of the negative angle, so the direction, the amount that we went down vertically, right, when we went down by negative theta, right, should be the same as the positive amount, but in the negative direction. Yay. Okay, we're getting there. We're getting there. Okay, so now, why? What's the point, right? These are fundamental identities. These are fundamental things that can simplify a whole lot if they show up on a regular basis, right? So, for example, let's take a look at this, right? Let's say tangent of 45 and tangent of negative 45 degrees, right? So first of all, let me do this again. I'm going to grab my unit circle, throw it in here. And why won't it let me move it? It will let me move it. There we go. Okay, here's my unit circle. Okay, hopefully you guys see it. 45 degrees is that one. Let me actually make this bigger, huh? There we go, mostly, kinda, maybe. There we go, okay. 45 degrees is this one, right? So we need those two values right there. So we know tangent of 45 degrees, just by looking at our unit circle, is going to be positive root 2 over 2 divided by root 2 over 2 on the bottom, because it's sine divided by cosine, so the y divided by the x, right? And this is equal to 1. Okay? Now, we know that tangent is odd, right? So then this means that the tangent of negative 45 degrees should be equal to the negative tangent of the positive 45 degrees, 45. Okay? We know the positive 45 degrees is equal to 1, so then that means this has got to be equal to negative 1. We are done. That is the point behind the identities. Now, This is very basic, right? But it gets the point across, okay? Sometimes you might need to reduce stuff. This is where it comes in handy, okay? Next one. Secant 5 pi over 6 and secant of negative 5 pi over 6. So we know that secant of 5 pi over 6, right? Secant is 1 over cosine. So this is going to be 1 over cosine of 5 pi over 6. So in this case, 5 pi over 6 is this angle right here. Right? We need these two values. In particular, we need the cosine. 1 over negative root 3 over 2. And if you compute this all out right, you get, I'm going to actually go down here, 2 over negative root 3, negative 2 root 3 over 3. Bam. Right? Oh, nope, not bam. We were looking for this, okay? Secant is an even function, so that means that the negative in here sort of goes away. So this is equivalent to secant of 5 pi over 6, which means this is going to be also equal to negative 2 square root 3 over 3. We are done. So what basically we did, right, is instead of going to find secant of negative 5 pi over 6, we just found secant of 5 pi over 6. And since we knew it was an even function, right, it's equal to the negative 1 anyway. We are done. Okay. We're getting closer to the good stuff. Now we're getting, this is the good stuff right here. Excuse me. In physics and in the higher ends of chemistry, and if you ever do math for the rest of your life, right, there are going to be a fair amount of trigonometric expressions that you might need to reduce, okay? We'll start off with real simple baby steps, right? But this is essentially what we're going to be doing. We're going to be converting, we're going to be proving certain trigonometric identities. And these are a handful of them, okay? So, and in this one, what I'm going to do, right, for A, is I want to use my identities to simplify secant divided by tangent. This actually simplifies to something nicer, something a lot smaller, a lot more concise, okay? But what? What does it convert to, right? What does it simplify to? Okay. For these quick checks that you guys see below, right? The best idea, okay? The game will get a little bit more complicated. But for now, the best idea is to grab everything and just change it all back to sine and cosine. So what do I mean? So I'm going to do this. I need secant of t divided by tangent of t, right? We know from way back at the beginning of the chapter, right, of this section, secant is 1 over cosine of t. Okay? And tangent is sine of t divided by cosine of t. Hopefully that makes sense. Got it? All right. Now we have to play around with some fractions. So if you guys remember how to work out fractions of fractions, right? The way that we were working it out before is that we can grab this, right? So 1 over cosine of t. Ugh. We can rewrite it for now, right, as this, divided by sine of t over cosine of t, right? Now, if you recall, if you have this, right, the division of fractions, you can flip the second one and make it into a multiplication. And that's exactly what we're going to do. The first one stays. So 1 over cosine of t. That one stays. Times cosine of t over sine of t. Okay? And what we have now, we have a multiplication, right? So that we can go straight across. So this is going to be cosine of t. Let me make this nicer, huh? Cosine of t all over cosine of t times sine of t. Okay? If you notice, there's one cosine of t on the top and another one on the bottom. They cancel. You get left with 1 over sine of t. And 1 over sine of t, right, way back from the beginning of the section, that is cosecant of t. And we are done. So what we just did is this, that we simplified this. We simplified secant t divided by tangent t. And that is just the same thing as writing cosecant of t. Done. Okay? Next one. Do the same thing. I have a tangent and a cosine, right? So I'm going to grab the tangent and I'm going to switch it to what I need it to, right? So tangent of t times cosine of t. This is the same thing as writing this, right? Sine of t divided by cosine of t times cosine of t divided by 1. I can grab anything I want and throw it over 1, right? This is equivalent to sine of t times cosine of t divided by cosine of t times 1. Leave the 1 away, right? Again, there's a cosine of t on the top, cosine of t on the bottom, and they're being multiplied. They're being multiplied. That's a multiplication in between, right? All I get left with now is sine of t. And we are done. So this statement right here, tangent times cosine, is the same thing as writing down sine of t. We are done. Okay? We're going to get pretty good with this. And we're going to do it whether you like it or not. Okay? This is actually what happens, like I said, in the higher ends of your engineering courses, your natural science courses, so that's chemistry, that's physics, right? And if you do math for the rest of your life, right, this is definitely going to show up, okay? All right, quick checks after that, and then lecture questions, okay? If you got any questions on anything I just covered, ask me during our quick check times during class, or come down to see me at my office hours, cool? Besides that, happy studying.